Hey learners, welcome to Mac. So learners, in this video we will see a coding question which was asked in Google and Facebook coding interview and which is based on a subarray concept. Okay, so I have explained the concept of subarray in my previous videos. So if you haven't watched that video, I would recommend just go and watch that video, and I will just add it in the I button, pin it in the comment box, and also add it in the description. And apart from that, in our just last video, uh, I have just explained a problem based on the subarray concept only. So I would recommend just go and watch that video also. So now let's proceed. So if there is an array, we have to get the total sum of all subarrays. Okay, so what does this mean? Okay, let's understand with an example. So if there is an array, okay, so there will be a set of subarrays for it. So how many subarrays are there? So we have to get the total number of subarrays. So we can get it through what? We can get it by taking the value of n, multiplying it with n plus 1 and dividing it with what? 2. So n is what? The size of the array. So if the array is having 4 elements, so the total number of subarrays will be what? 4 into 4 plus 1 will be 5, divided by 2 it will be what? 10. So there will be 10 subarrays. You can see there are 10 subarrays. Okay, so subarray sum from index 0 to 0 it will be what? 1. Okay, from 0 to 1 will be what? 1 plus 2, 3. From 0 to 2 will be 2. Like this we will get the subarray from 3 to 3 will be 3. So with this we are getting the sum of each and every subarray. Okay, so now what we have to do, we have to get the sum of all these sums and return the total sum for it. Okay, so you can see that we have to get the total sum of all subarrays. So these are the subarray sums and we have to get the total. Okay, in for this example it is 22 and it is the total sum of all subarray sums. So now how to get it, how to do it with a coding. So just see over here, I have written a pseudo code that if we have to get the total sum of all subarray sum, we are taking an array, n is the length of the array, we are taking a variable is total sum starting with 0. So here you can see then there is a for loop which is starting from I is equals to 0 and it will goes on to n minus 1. So is an element sum so far which is starting from 0, and here we are using the carry forward technique. In the last video also I have just explained the use of carry forward technique in getting the sum for each and every subarray. So here you can see there is an inner loop which will start from j is equals to I and it will goes on to n minus 1, and here the sum so far will contain the sum for each and every subarray which will start from the index I. So if the index I is 0, it will for all the subarray which will starting from 0 to the jth index, the sum so far will contain the sum, as for every loop it is adding the element of the jth index to itself. And okay, so with this we can just get the subarray sum. Okay, and we will add that subarray sum to the total sum variable. Okay, so with this, for each and every subarray we are getting the sum, so with the sum so far and adding to the total sum. So with this, when this loop ends, when the I will become 1, so the subarray will start from the index I is equals to 1, and it will goes on to n minus 1, and the sum so far will become 0, and then it will again start adding the elements, and the subarray will be the sum of that particular subarray will be received, and with that will add to the total sum. And when all these elements, this loop and this the outer loop will end, will at last will we are returning the total sum. Okay, so with this approach you can see that whatever the time complexity for it, so the outer loop is running for n times, the inner loop is running for n times in the worst case. So the time complexity for it will be 1 order of n square, and space complexity will be 1 order of 1, as we are not using any array list. Okay, that's why. So you can see that the time complexity is what, order of n square. So it is the last term complexity. So is there any way to reduce the time complexity? There should be any way. Okay, so just think about it, and if you know the solution, just comment in the comment box. Okay, so now just proceed to this and try to optimize the solution. Okay, so here we are working on the optimization. So just try to understand a scenario. Okay, so here's an array with 3 elements. The total number of subarrays will be what? 3 into 4 by 2 will be what? 6. So there are 6 subarrays. So the subarray is starting from 0 to 0, 0 to 1, 0 to 2, 1 to 1, 1 to 2, and 2 to 2. And these are the sum for each and every subarrays. Okay, so what we are doing over here, we can see that when there is a subarray from 0 to 0, the element of the 0th index is added, and it is returned, the value is returned. So to get the subarray from 0 to 1, the element of the 0th index and the 1th index is added and return the value. So getting the subarray from 0 to 2, the element of the 0th index plus the element of 1th index plus the element of the 2th index, all these will be added and will be returned for this subarray. Okay, when for the subarray from 1 to 1, the element of index 1 will be added and will be returned. For subarray of 1 to 2, the element of index 1 and element of index 2 will be added, and for the subarray of 2 to 2, the element of index 2 is added, and at last when you add all these sum of subarrays, we are getting 21. You can see these are the elements which is contributing towards the total sum. Okay, you can see that how many times the element A0 is contributing. It is contributing 1, 2, 3. So 3 into element of A0 plus how many times the element of index 1 is contributing. It is contributing 1, 2, 3, 4. So 4 into the element of index 1. So now just see how many times the element of index 2 is contributing. 1, 2, 3. So 3 into the element of index 2. So element of 0th index is what? Minus 1. So 3 into minus 1 plus 4 into element of index 1 is what? 3. 4 into 3 plus 3 into element of 2th index is what? 4. So 3 into 4. So it is resulting in 21. You can see this both sum are equal. Okay, so if in anyhow we know that how many times each element is contributing towards the total sum, okay, then we can get easily the sum of the total sum. for all the subarray sum. Okay, so we have to get the contribution technique for each and every element. Okay, with this just and with this we can just get the total sum easily in less time complexity. So I have just made another example with 4 elements. You can see with 4 elements, this set of elements will be there, which is contributing towards the total sum. Okay, you can pause the video and just see it. Okay, and at last the number of times which is contributing, if we multiply it by that number, the count number, and if we multiply by that count number, and finally we'll add towards the sum, we will get the total sum. Okay, so what is the contribution technique? So for every element, the contribution technique is what? I plus 1 into and minus I. Here I is what? The index of that element, and n is what? The size of the array. Okay, so how we reached to the solution? So just try to understand. Okay, so how many times each element will appear in the total sum? So to understand this, I need your complete attention. So just focus. Okay, so now just see. Here is an element array. Okay, so here you can see, for suppose for index 1. Okay, for index 1, if we want to get the number of times it will contribute in the total sum, so what will be the number of times it will contribute? So how many times the element of index 1 will appear in the set of subarrays? So when you start from 0th index, so from 0 to 1, this subarray will contain the element of index 1 from 0 to 2, from 0 to 3, from 0 to 4, from 0 to 5. All these subarrays will contain the element of index 1. Then when we start from 1 to 1, from 1 to 2, from 1 to 3, from 1 to 4, from 1 to 5, all these set of subarrays will contain the element of index 1. Okay, so how many times it is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is there how many times? It is 10 times. Okay, so element 1 in this array will contribute 10 times towards the total sum. Okay, so now see that how many times the index 1 will contain, just such as the starting index and end index. So we have to get the how many times this 1 will contain. So the subarray which starts from 0 to 1 will contain the index 1 element, from 0 to 2, from 0 to 3, from 0 to 4, from 0 to 5. All these set of subarrays will contain the index 1 element. From when we start from index 1, from 1 to 1, from 1 to 2, from 1 to 3, from 1 to 4, from 1 to 5. All these subarrays will contain the index 1 element. Okay, so this side is 2 and this side is 5. So we will multiply 2 into 5, it will result in 10. So you can see 10 is same as here, the answer. So for this we can get the number of times an element will contribute towards the total sum. Okay, so if you haven't understood, just focus and just see another example. Okay, see over here. Okay, suppose we want to get the contribution technique means to get the contribution number for the index 2. Okay, so such as from index 2, what are the subarrays which will contain the index 2 element? So subarrays containing starting from 0 to 2, 0 to 3, 0 to 4, 0 to 5. All these subarrays will contain the index 2 element. Then when we start from 1, from 1 to 2, from 1 to 3, from 1 to 4, from 1 to 5, all this set of subarrays will contain the index 2 element. And then when we start from 2, 2 to 2, 2 to 3, 2 to 4, and 2 to 5, all the set of subarrays will contain the index 2 element. Okay, so how many times is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, and the answer is 12. So index 2 in this array is contributing towards the total sum for 12 times. Okay, so how many times this index 2 is containing? So we can see that, so from the starting index to the index, so we will see that which will start from 0, it will goes on to 2. This subarray will contain the index 2 element. From 0 to 3 will contain the index 2 element. From 0 to 4, from 0 to 5, all this subarray will contain the index 2 element. Then from 1 to 2, 1 to 3, 1 to 4, 1 to 5, all this set of subarrays will contain the index 2 element. From 2 to 2, 2 to 3, 2 to 4, 2 to 5, all the set of subarrays will contain the index 2 element. So this side is 3, this side is 4, so we will multiply this and we will get the times, the number of times this element will contribute towards the total sum. Okay, so now just see that if there is an array, here is the ith index, and how many times the ith index element will contribute towards the total sum. So the subarray from here is will be what? From 0 to ith elements, from 0 to ith elements. So what will be the total number of elements in this? I minus 0 plus 1 will be what? I plus 1. And the subarray which contains, and the subarray which is starting from I to n minus 1, from I to n minus 1. So what will the total number of elements? So n minus 1 minus I plus 1. So it will be what? N minus I. So with this we are getting the contribution technique that I plus 1 when multiplied by n minus I, we will get the number of times that particular element will contribute towards the total sum. Okay, so now just see your pseudocode. Here we are taking an array. Here the n is the length of the array. Total sum is starting from 0, for starting from I is equals to 0 to I is equals to n minus 1. Here C is what? The contribution technique for this index element. So how to get that? So I plus 1 will be multiplied by n minus I. You can see I plus 1 will be multiplied with n minus I, and we will take the contribution technique of that element and multiply it with that element and add it in the total sum. And at last, when this loop ends, we are returning total sum. With this, we will get the total sum with the optimized approach. So just see what is the time complexity for it. So you can see that this loop is running for n times, and this is the only single loop. So the time complexity will be what? Order of n. And what is the space complexity? Order of 1, because we are not taking any array list and other things. Okay, so with this we are getting the optimized approach, and yeah, with this we are getting the optimized solution. So learners, this is it for this video. So if you like this video, just click the like button and do give us a feedback, whatever you liked in this video. If you need to improve anything, just write it in the comment box. It will help us in improving our teaching lecture. And do subscribe to our channel. We will be coming with more data structure videos, and just hit the bell icon. Thank you.